Hi everyone, welcome to my Max Academy. In this video, we'll continue with the chapter Determinants from your 12th standard CBSE Mathematics. I'll continue with the exercise, miscellaneous exercise in page number 142, problem number 9. It says evaluate the value of this determinant. You need to evaluate the value of this determinant, which is your problem number 9 from miscellaneous exercise, page number 142 in your textbook. So to evaluate this, we'll call this as suppose delta equal to. So solution is, so delta equal to, so I'm calling this as delta. So delta equal to x, y, x plus y, y, x plus y, x plus y, x, y. Now let's try to see whether we can apply some of the properties of determinant so that we can find the value of this determinant in an easier way. So for that, we'll try to see if we can make as many zeros as possible in a particular row or column, right? So to do that, we'll also try to see whether if we add any two rows or all the three rows, or any two columns or all the three columns, and see whether we get the same element in any one of the rows. All the elements in a particular row or all the elements in a particular column should be same. In case if we apply any of the row operations or column operations. Suppose if you observe, if I add all the three rows, R1 equal to R1 plus R2 plus R3, I'll get 2 times x plus y. If I add all these three, y plus x plus y plus x, I'll get 2 times x plus y or 2x plus 2y. If I add this, x plus y plus x plus y will give me 2x plus 2y. So all the elements of row 1 will become 2x plus 2y or 2 of x plus y. When if I do this operation, if we do the operation, R1 implies R1 plus R2 plus R3. Right? So if we do this, then what do we get? So our delta becomes, so this will become 2 times x plus y. This will also become 2 times x plus y. This will also become 2 times x plus y. So if you add them, x plus y will be 2x plus 2y. Again, this will be 2x plus 2y. This will be 2x plus 2y. So we are adding R1 plus R2 plus R3. So R1, every element in R1, we are applying this operation. So you get this. Then second row and third row, no change. As it is, I am writing x plus y, x and y. Now let's take 2 of x plus y out. So your delta becomes 2 of x plus y. Then you get 1, 1, 1. Because all the elements in row 1 is same. So whenever any row or any column has same elements, then you can take that out of the determinant. Then it becomes 1, 1, 1 because I've taken 2 of x plus y out. So this becomes y, this is x plus y, this is x, this is x plus y, this is x, this is y. Now, the moment we get 1, 1, 1, it is very easy to make these two zeros. We can do this minus this. So C2, this is column 2. Column 2 is column 2 minus column 1. Similarly, we can do C3, this is column 3 minus column 1. Right? So if you do that operation, suppose if I apply the operation here, suppose if I say C2 implies C2 minus C1 and then C3 implies C3 minus C1, right? Colon. If I apply these two operations, so what it becomes? So your delta becomes is 2 of x plus y, then determinant of, no change in the first column because we are changing only column 2 and column 3. So I'll write the first column as it is, 1 y x plus y. Then C2 is C2 minus C1. So 1 minus 1 is 0. Then x plus y minus y. C2 minus C1. So C2 x plus y minus y will give me x. So similarly, x minus x plus y will give you minus y. So similarly, 1 minus 1. C3 minus C1. C3 minus C1. So C3 minus C1. So 1 minus 1 is 0. Then x minus y will give you x minus y. Then y minus x minus y minus of x plus y will give you minus x. Right? So then what it becomes? So it becomes 2 times x plus y of, right? Now if you expand this using along row 1, because it has 2 zeros, so now we can expand. So we say 1 into x into minus x is minus x square minus y into x minus y will become plus y of x minus y. So that will become 2 times x plus y into this will become minus x square, this will become plus yx minus y square. Right? So suppose if I take minus common from these two, it will become minus 2 of x plus y into x square minus xy plus y square. If you take minus from this, minus common, if you take that out, so that is delta. So delta becomes minus 2 of, now what is this? X plus y into x square minus xy plus y square is x cube minus y cube, the identity, right? So x cube plus y cube, right? A cube plus b cube. A cube plus b cube is a plus b into a square minus ab plus b square. Right? So this becomes like x cube plus y cube. Right? So this value of this x plus y into this is x cube. So you get minus 2 of x cube plus y cube. So that is the value of this determinant. Fine. So all of you can pause the video, take the notes. I am moving to the next problem, which is the 10th problem. So 10th question is, it says in evaluate, right? It is evaluate 1 1 1, then x plus y and y. Oh, sorry, x. Then y x plus y, y x plus y. Now we have to evaluate this determinant. Evaluate this determinant. That is your question number 10. Right. So now what we have now delta. Delta is this. Suppose if I call this as delta. So 1 1 1 x plus y x y x plus y. Now again, the moment we see a particular row or a particular column with 1 1 1, then it is easy to make these two zeros by using this one can be made 0 by taking this one minus this one. That will make this 0. Again, this minus this will make this 0. So we can apply the condition or the row operation as R2 implies R2 minus R1. That will make this 0. So 1 minus 1. R2 is this is R1. R2 minus R1 will make this 0. So similarly, we can apply R3 implies R3 minus R1. So semicolon. Okay. So I'm going to apply these two operations. Then what do we get? So our delta becomes, first row no change. This is 1 minus 1 is 0. Then x plus y minus x will give you y. This minus this. Again this minus this gives you 0. Y minus y is 0. Then R3 minus R1. Right? So R3 minus R1. So 1 minus 1 is 0. Then x minus x is 0. X plus y minus y will give you x. Fine. So now we have got two zeros in these two as well as these two. So we can expand along C1. So expanding along C1, column 1, expanding along C1. So what is our delta? Delta becomes 1 into this into, we'll close this particular row and this particular column. So x into y is xy minus 0. Then other twos are 0. So we don't have to write. So finally answer is xy. What is the answer of delta? So the value of this determinant is x into y, which is xy. Fine. So all of you can pause this video and take the notes. I will go to the next one. I'll go to the next problem, which is problem number 11. So 11th problem. Yes, we have to show that using properties of determinants, prove that. We have to prove that determinant alpha, beta, gamma, alpha square, beta square, gamma square, beta plus gamma gamma plus alpha, alpha plus beta, that is equal to beta minus gamma into gamma minus alpha into alpha minus beta into alpha plus beta plus gamma. We have to prove this. We have to show that the value of that determinant equal to this. Value of this determinant equal to this. This is what we have to prove. Right? Now let's go to the solution. Suppose if I call this as delta, delta equal. I'm calling this entire thing as delta. Right? So it is this determinant. We have to show that this determinant equal to this. Okay. Now, so now what we'll try to see, we will try to see if we can make any particular row or any particular column's element has same. That is what we will first check. Is it possible? If it is already same, we can take that out of the determinant, then it will become 1, 1, 1. Once it becomes 1, 1, 1, we can make two of them 0. If they are not same, then we'll try to see if we can make any particular row or any particular column having the elements as same. Can we make the elements of a particular row or particular column same? Now if you observe here, suppose if I add C3, column C3 with C1. So beta plus gamma plus alpha will give you alpha plus beta plus gamma. Then gamma plus alpha plus beta will give me alpha plus beta plus gamma. Alpha plus beta plus gamma will give me alpha plus beta plus gamma. Then everything becomes alpha plus beta plus gamma in column 3. When if I apply the column operation as C3 implies C3 plus C1. If I add the column 3 elements with the corresponding elements in column 1, then all the elements of my column 3 becomes alpha plus beta plus gamma. Then I can take that out of the determinant, then that will become 1, 1, 1. Then we can make two of the, among 3 ones, 2 of the ones can be made 0 easily. So we'll apply this. So delta equal to, after applying this, so C1 no change, C2 also no change, alpha square, beta square, gamma square. Then your C3 is this plus this. You'll get alpha plus beta plus gamma. And again alpha plus beta plus gamma, because C3 plus C1, again C3 plus C1 will give you alpha plus beta plus gamma. Alpha plus beta plus gamma. Now alpha plus beta plus gamma is present in all the elements of column 3, so that can be taken out of the integral. Sorry, out of the determinant. Sorry, I was teaching integrals in the previous class. Okay, so we can take this out of the determinant. So your delta becomes alpha plus beta plus gamma times into this one, alpha, beta, gamma, alpha square, beta square, gamma square, right? Then this is 1, 1, 1, because we took alpha plus beta plus gamma out. Now if you observe, we have got this, we have got in the answer, we have got this factor. Now we should get these 3. The value of this should be equal to these 3, which we can easily make it, because the moment you see 1, 1, 1 in a particular row or a column, you can make two of the ones 0 by applying the operation. We can make this as 0 by doing R2 is R2 minus R1, and R3, row 3, this one is row 3 minus row 1, will make these two 0. Then we can easily expand. So we are going to apply the operation. R2 implies R2 minus R1, semicolon, R3 implies R3 minus R1. So if I apply this, so my delta becomes, that is equal to, delta is alpha plus beta plus gamma into, so row 1 no change, I'll write row 1, alpha, alpha square 1. Now this becomes R2 is R2 minus R1, so beta minus alpha. So this will become R2 minus R1 is beta minus alpha. I'll get beta minus alpha, right? Probably I will write little bit here. So alpha square, this is 1. Then beta square minus alpha square. So beta square minus alpha square. Then 1 minus 1, 0. When I apply R2 minus R1 operation, R2 is this, minus R1. Again R2 minus R1. R2 minus R1, 0. Then again R3 minus R1. R3 is gamma. R3 is gamma. R1 is alpha. So gamma minus alpha. So gamma minus alpha. Then gamma square minus alpha square. Then 1 minus 1 is 0. Now if you observe here, in the second row and third row, second row and third row, we see in the second row beta minus alpha is there, beta minus alpha is here also, because beta square minus alpha square can be written as beta plus alpha into beta minus alpha. So this also has got beta minus alpha, this also has get a beta minus alpha, 0 also has beta minus alpha, because 0 can be written as 0 into beta minus alpha. So all the elements of row 2 has beta minus alpha. So that can be taken out of the determinant. That can be taken out of the determinant. So your delta becomes alpha plus beta plus gamma into, from the second row, we can take beta minus alpha out because it is present in each element of row 2. Similarly, gamma minus alpha is here. Here also we have gamma minus alpha, because gamma square minus alpha square can be written as gamma minus alpha into gamma plus alpha, a plus b into a minus b, right? Which is a square minus b square. So if I take gamma minus alpha also out, so I'll get gamma minus alpha out of the third row, then my determinant becomes like this. Then in the second row I have taken beta minus alpha out, so this will become 1. Here I took beta minus alpha out, I will have beta plus alpha, and this is 0. Again here we took out gamma minus alpha, so this will become 1. Here also we took out gamma minus alpha, so it will become gamma plus alpha, then this is 0. Okay. So now what we can do, we can try to expand the determinant. So delta, so we got 2 zeros. So we can expand along the row C3, column 3. So expanding along C3, column 3 we are going to expand. So delta is, this value is already there, alpha plus beta plus gamma into beta minus alpha, gamma minus alpha. This I am writing as it is into. Now we are going to expand through C3. So this is the position of A13 element, A13, first row, third column. So this is 1 into, we'll close this particular row and this particular column. So 1 into gamma minus alpha is gamma minus alpha, gamma plus alpha. 1 into gamma plus alpha, so if I close these two, this into this, minus 1 into beta plus alpha, minus beta plus alpha. That will become minus beta minus alpha, minus of both, right? So your alpha will get cancelled. We'll get gamma minus beta. So finally what we have got, so I'll write here. So finally we got our delta as, so delta becomes, delta equal to alpha plus beta plus gamma into beta minus alpha into gamma minus alpha, then gamma minus beta, right? Gamma minus beta. Now what we should get, so we should get alpha plus beta plus gamma, which we got this. Then beta minus alpha, beta, but we have alpha minus beta. So we should change these two. When we change these two, we'll get one negative. If I write beta minus alpha as alpha minus beta, then you will have one negative. Minus will be there. So this will give, if I change this, I will have a negative here. This is gamma minus alpha, no change here. They are matching. This is gamma minus beta, but we need beta minus gamma. So this also should be changed. This also should be changed. So this will give you one negative. This will give you one negative. Negative will become positive. So we are going to change this and this. So if we change this, then delta will become alpha plus beta plus gamma into alpha minus beta. I will have one minus. Then this I am not changing, gamma minus alpha. I am going to change this as beta minus gamma. So this will give me another minus. So minus into minus plus. So you got this. So which is matching with alpha plus beta plus gamma plus beta minus gamma, which is this. Gamma minus alpha, which is this. Alpha minus beta is this. So if you want, we can again write it in the same order. Beta minus gamma, we can write this first. Even if you stop here, it is okay. Beta minus gamma, then gamma minus alpha, then beta minus gamma, alpha minus beta minus gamma, gamma minus alpha, then alpha minus beta into alpha plus beta plus gamma. So we have proved that. That is, which is equal to the RHS. Fine. So we have showed that they are matching. Your LHS is matching with the RHS. Fine. Okay. Now let's go to the next question, which is 12th one. So all of you can copy this. I'll pause the video, take the notes. I'm going to erase now. Okay. Let me erase everything and I'll start from here. Okay, so now what we have is the 12th question in your textbook, which is determinant x square 1 plus p x cube y square 1 plus p y cube, then z square 1 plus p z cube. You have to prove that this is equal to, we have to prove that the value of this is equal to 1 plus p x y z into x minus y into y minus z into z minus x. This is what we have to prove. We have to show that the value of this determinant is equal to this. We have to prove this. Right? So now the solution is, we'll take this one, the LHS, and we'll prove that the value of the determinant equal to this. So I'm going to take the LHS. So LHS is determinant x square 1 plus px cube y square 1 plus py cube z square 1 plus pz cube. Right now, again, if you observe, if a particular row or a particular column's elements are expressed as sum of two or more terms, then the determinant can be expressed as sum of two or more terms. So one of the properties of determinant. So we'll apply this property and we can break this into two parts. So this will become x y z x square y square z square. Then this can be broken into two. So 1 1 1 plus again x square y z y square z square, and I have to write px cube py cube and pz cube. Right? So you can use this, that is there in your property. We are applying the property number, I think it's property 5, where if a particular row or a particular column, this is by property 5 in your textbook in page number 113. Right? So what it says, property 5 says is, if a particular row or a column elements are expressed as two or more terms, then the determinant can be expressed as sum of two or more terms. Right? So using property 5, so I can say property 5 is used here. Property 5 of the determinant is used here. Now let's try to understand what happens. Now after this, if you see this is x, y, z, x square, y square, z square, 1 1 1 determinant, plus now if you observe here, we see p is common in column C3, p. So that can be taken out of the determinant. From p is taken out. Again, x is common in row 1. This has x square, x cube. So x also can be taken from row 1. So p is taken out of column 3 and x is taken out of row 1 and y is taken out of row 2 because y is present in each element of row 2. Similarly, z is present in each element of row 3, so z is taken out. So this determinant reduces to, so this, if I take x out of the first row, it will become 1 x, then it will become x square, and p is also taken out, so it will have only x square. So similarly, this is y is taken out, so it will become 1 y square, y is taken out, so y, here y is taken, it will become y square, also p is also taken out, so it will become y square. Similarly, 1 z square. So what we have done, we took p out of the column 3 first, then we took x out of row 1, y out of row 2, z out of row 3, because they are common, they are present in each element of the rows. So now it has become like this. Fine. Now if you observe, now again what we can do, we can shift to this. So I can swap this and this. So 1 1 1 will come here, this will go here. When I interchange any two or column, then the value of the determinant changes by sign. Again, one more property of the determinant. So if I swap these two, so I'm actually swapping my C2 and C3, right? Column 2 and column 3 if I swap, so that I want to make this determinant look like this determinant. So I want 1 1 1 to come to the first column. So first I'm shifting to the second column, then I'll shift it to the first column. So if I swap this, then this is x, y, z. This will come here, this will go here. So it will become 1 1 1 x square, y square, z square. So they will have a minus, because whenever you are interchanging any two columns, any two rows, then the value of the determinant changes by sign. So plus, this is p x y z of determinant 1 1 1 x y z. This I am writing as this x square, y square, z square. Fine. Now again we can swap these two. I can again interchange my column 2 can go here, column 1 can come here. Then 1 1 1 will go here, x y z will come here. Then this entire determinant will matches with this determinant. So if you swap this, again one more minus will come, that will make this minus as plus. So if I interchange again my C1 and C2, that is the meaning of interchanging C1 and C2. Both the sides I'll put arrow. Then it becomes plus. This minus, one more minus will come. Because whenever you interchange a row or column, one more minus will come. That will make this minus as plus. So it will become plus. It will become plus. Then you get 1 1 1 x y z x square y square z square plus this becomes p x y z. So which is p x y z of determinant 1 1 1 x y z x square y square z square. Right, this I have written as this. Now both the determinants are same, so I can take that common. So if you take this determinant common, right, then I will have 1 1 1 x y z x square y square z square. If I take this common, right, then I will have, if I take this common from this term, if this is taken out, I will have 1 here, plus this will become p x y z. Right? So if you multiply here, now this determinant into 1 will give you this determinant. So determinant is nothing but what? It's a number. Right? If a number is common in both, so this is present here, these two are common. So I am taking that out, then this will become 1. And if it, since I took this out here, this will have only pxyz. So if you multiply this into 1, you'll get back this. Again, this determinant into pxyz will give you pxyz into this determinant. Fine? Now we'll have to evaluate a little bit to get this answer. So now again, whenever you see 1 1 1, we can make these two 0 easily, right? By doing R2 is R2 minus R1, R3 is R3 minus R1. Since you have two ones, the moment you have two, all the rows are one, all any particular row or particular column having all the elements as 1 1 1, then we can easily make two of them as 0. By using here, we will apply R2 implies R2 minus R1 colon semicolon, R3 implies R3 minus R1. So then you get equal to, so first row no change, second row will become 1 minus 1 0, R2 minus R1 y minus x, this will become y square minus x square, right? And this is 1 plus p of x y z. Then R3 minus R1 0, z minus x is z minus x, z square minus x square is z square minus x square. Now if you observe, the second row has y minus x common, because this has y minus x, this has y square minus x square will have y minus x into y plus x. This 0 also has y minus x, because 0 can be written as 0 into y minus x. So y minus x common in the second row. All the elements of row 2 has y minus x. I am taking that out of the determinant. Similarly, all the elements of row 3 has z minus x, so I am taking z minus x also out, which is similar to the previous problem that we did here. Now what do you get? You get 1x x square, 0 1 y plus x, because we took 0, then y minus x is taken out, it will become 1. Here y minus x is out means you will have y plus x, because y square minus x square is y minus x into y plus x. And y minus x we took it out, so we will have y plus x. So this becomes 0, then z minus x is common taken out, so 1, here z minus x is taken out, it will become z plus x. Right, and then we have this, probably I'll write this here. I'll write this 1 plus pxyz here. This is equal to 1 plus pxyz of these two. Right, it is here, I'm just writing it here. So multiplication only, right? I can write this, then determinant here. So now, so what do we get? We get 1 plus pxyz into y minus x into z minus x. Now we can start evaluating, we can expanding. We can start expanding this determinant along C1. So you get 1 into z minus x is z minus z plus 1 into z plus x is z plus x, minus 1 into y minus 1 into y plus x is minus y minus x. So x will get cancelled, you get z minus y. So you get 1 plus pxyz into y minus x into z minus x into z minus y. But what we should get? We should get 1 plus pxyz, which is this. Then we need x minus y, but we have y minus x, so we have to interchange these two. We have to write y minus x as x minus y. Then we will get one negative, because y minus x can be written as minus of x minus y. So if I interchange this, one negative will come. Then z minus x is same. This is z minus y, but we want y minus z. This also we should change. So this and this we have to change. Those will give you minus minus, that will make it as plus. So you get 1 plus pxyz, 1 plus pxyz into, this will become x minus y. So I have 1 minus into x minus y into y minus z. I am going to write z minus y as y minus z. This is another minus. When you interchange these two, we will get another minus. So minus into minus will give you plus. So 2 minus I got, so it will become plus. Then z minus x is, I am writing this as it is. I am not changing this. I am not swapping these two. So which is your RHS? We started with LHS. We started with this and we proved that it is equal to this. This P1 times 1 plus Pxyz into x minus y into y minus z into z minus x, which is equal to the RHS. So we have shown that the value of this determinant is equal to this. Right? So all of you can pause the video and take the notes. I will stop the session here. You can watch my next session for the continuation of this. Thank you for watching. See you all in the next video. Thank you.